Welcome to EDU World Space.
Hey everybody! So we got to show that the heavy damping of body release from an arbitrary position with an arbitrary initial velocity cannot pass more than once through its equilibrium position. So we have this equation here given to us, E1, 2 plus C2 E lambda 2t, and then we have the velocity, which is also your derivative of this equation, and you can denote derivative with just the x little dot above it. If you're curious, that is one way to write it. There's actually a few ways to write it in mathematics. At this point, it kind of just depends on what your professor prefers and really what you prefer too. Okay, and so we have these initial conditions: t equals 0, x equals x naught, v equals v. Oops. V does not equal x. Oh, which is in an x mode. There we go. V naught. So for that, if we're just going to plug in this into these two stuff, okay? And because of that, we have x equals x naught, c1 plus c2, because e's to 0s equal 1. And then we have the v naught equals, looks like we have c1 lambda 1, okay, plus c2 lambda 2. And for this, if we get the we want to get the c2 by itself, so for that it's going to be equal to x naught minus c1, and we're going to plug that into here. And when we do that, we got v naught equals c1 lambda 1 plus x naught minus c1 lambda 2, okay? And now we end up with c1 lambda 1 minus lambda 2. And let me fix this lambda here because it kind of looks like an x. Oh, lambda 1, okay? Plus x naught lambda 2 minus v naught equals 0. And we're just going to get this on to one side. And then it's x naught lambda 2 plus v naught. And if we solve for c1, it's going to be minus x naught lambda 2 plus v naught lambda 1 minus lambda 2. And if we did it with c2 instead, such as if we had c1 equals x naught minus c2, we will have something very close to this, and it's not going to be as extreme. Okay. Now, what we can do is, oops, I was looking at the wrong thing. I apologize. This is what happens when you're reading your notes and you're trying to figure out what you're saying. We got lambda 1 x naught plus v naught over lambda 2 minus lambda 1. And for this, we can flip where we put v naught. Okay? So now we're just going to plug it into our x equation that we had above. So here we have v naught, negative v naught, plus x2xo minus h lambda 2 minus lambda 1 times e lambda 1 t plus lambda 1 x naught plus v naught divided by lambda 2 minus lambda 1 equals e lambda 2 divided by t, times t, my bad. And here we're just going to simplify it a little bit more. So we have lambda 2 minus lambda 1 v naught plus lambda 2 x naught times e lambda 1 t. Oops, we don't need that. There we go. Okay. Plus negative lambda 1 x naught plus v naught times e lambda 2t. Okay. And we're having this x equals 0. We're setting it to 0. And we're going to separate everything. So we're going to times this over here. So it's going to be crossed out. And now we're just going to put these two on one side. So we're going to get v naught minus lambda 2 x naught times e lambda 1 t equals v naught minus lambda 1 x naught e lambda 2t. And now we're going to get the e's by themselves, and we're just going to go up here. So we have e lambda 1t, or we can do this better, lambda 1 minus lambda 2t equals v naught minus lambda 1 x naught divided by v naught minus lambda 2 x naught. And we're just going to take the ln up here. So we're taking ln, and when we do that, we have lambda 1 minus lambda 2 times t equals ln v naught minus lambda 1 x naught v naught minus lambda 2 x naught over here. And we're going to solve for t, and we end up with lambda 1 minus lambda 2 times ln of v naught minus lambda 1 x naught divided by v naught minus lambda 2 x naught. Okay, and this will only work for x equals 0. Okay, thank you guys.